Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Haikal bin Mama Ali. My metric number is 067283. In this video, we are going to present about Reduced Instruction Set Computer (RISC). Let's begin the presentation. First of all, we need to know what is RISC and CISC. RISC is Reduced Instruction Set Computer, and CISC is a Complex Instruction Set Computer. First, what is CISC? CISC is a chip that are easy to program and which make efficient use of memory. CISC was developed to make compiler development simpler. It shifts most of the burden of generating machine instruction to the processor. For example, instead of having to make a compiler write a long machine instruction to calculate a square root, CISC processor would have a built-in ability to execute this. It's because CISC is smaller program size and use only less memory call. Next, what is RISC, Reduced Instruction Set Computer? RISC is a type of microprocessor architecture that utilize a small, highly optimized set of instruction rather than a more specialized set of other instruction. RISC architecture represent an important innovation in the area of computer organization. RISC also is an attempt to produce more CPU power by simplifying the instruction set of the CPU. Both RISC and CISC designed to solve the same problem, but CISC going to the traditional way of implementing more and more complex instructions. But for RISC, try to simplify the instruction set. That means RISC is a microprocessor that is designed to perform a smaller number of types of computer instruction, so that it can operate a higher speed, perform more millions of instructions per second, or MIPS. Next slide. So, what problem with CISC? CISC use a large instruction set, require complex and potentially time-consuming hardware step to decode and execute the instruction. Because CISC is more complex, it will use more time to decode and execute the instruction of computer. Second, CISC is complex machine instruction may not match high-level language statement exactly, in which case they may be used. This will be a major problem if the number of language is more getting bigger. Third, CISC set designed with specialized instruction for only several high-level language will not be efficient when execute program of given language. That's all from me. I will pass the presentation to the next presenter.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazil bin Musa. My matrix number 067280. I will continue my friend's presentation. I will talk about the importance of reduced instruction set computer processor. There are several of importance, which is it use few powerful instructions, single clock cycle execution. Second, it is a register-based execution. Third, it is a highly pipeline superscalar architecture. Fourth, it uses fixed instruction format and fixed length instruction. computer if it is large register set or register Windows. The 6. It is hardwire control unit. And lastly, it is highly integrated architecture. Next slide is about the example of processor that use RISC architecture. SPA-RC or Scalable Processor Architecture is used 32-bit based processor which is come with integer unit IU that execute all of the instructions. It also has floating point unit FPU, which is the core processor that work concurrently with IU to perform arithmetic operation on floating numbers. Apart of that, it also has 69 basic instructions and a linear 32-bit virtual address space 4G, and also has 42 to 520 general purpose 32-bit register with 2 to 32 overlapping register windows. That's all from me.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Hafizullah bin Ehsinuddin. My metric number is 067281. Today I would like to talk about characteristic of reduced instruction set architecture, RISC. Although there have been a variety of methods to reduce instruction set architecture, they always have certain characteristics such as one instruction per cycle, register to register operation, simple addressing modes, simple instruction formats. So we will go through this feature in a little more detail below. The first characteristic is that each machine cycle has only one machine instruction. The time it takes to collect two operand from register, perform an ALU operation, and store the result in a register is called a machine cycle. As a result, RISC machine instruction should be no more complicated than micro instruction on CISC machine. That means RISC machine instruction should be no more sophisticated than micro instruction on CISC machine and should execute at a similar speed. With simple one cycle instruction, there is little or no need for microcode. The machine instruction can be hardwired. Such instructions should execute faster than comparable machine instruction on other machines because it is not necessary to access a microprogram control store during instruction execution. So we will go for the next characteristic. A second characteristic is that most operations should be register to register. With only simple load and store operation, accessing memory. Okay, RISC processes allow only special load and store operation to access memory. The rest of the operation work on a register to register basis. This feature simplifies instruction set design as it allows execution of instruction at a one instruction per cycle rate. A RISC machine set may include only one or two add instructions. For example, integer add and add with carry. Another advantage of such a design is that it fosters register optimization. That means keeping frequently accessed operand are kept in high speed storage. This emphasis on register-to-register operation is notable for RISC design, but in contemporary CISC machine provide such instruction but also include a memory to memory and mixed register or memory operation. So that's all from me. Thank you so much. We will go for the next presenter for the next characteristic. Thank you.
My name is Muhammad Naufal bin Suran and my metric number is 066420, and I will continue with the characteristic of reduced instruction set computer architecture. The third characteristic is the use of simple addressing modes. Simple register addressing is used in almost all RISC instructions. Several additional modes such as displacement and PC relative may be included. Other, from the elementary modes, more complicated modes can be created in software. Again, I repeat, this design aspect makes the instruction set and control unit easier to understand. And a final common characteristic is the use of simple instruction formats. Generally, only one or a few formats are used. Instruction length is fixed and aligned on word boundaries. Field locations, especially the opcode, are fixed. This design feature has a number of benefits. With fixed field, opcode decoding and register operand accessing can occur simultaneously. Simplified formats simplify the control unit. There are 3 points under this characteristic. First, it is possible to create more efficient optimizing compilers. With more primitive instruction, there are more opportunities for moving functions out of loops, reorganizing code for efficiency, maximizing register utilization, and so it is even possible to compute parts of complex instruction at compile time. For example, the X-390 move characters MVC instruction moves a string of characters from one location to another. Each time it is executed, the move will depend on the length of the string, whether and in which direction the location overlap, and what the alignment characteristics are. In most cases, this will all be known at compile time. Thus, the compiler could produce an optimized sequence of primitive instructions for this function. A second point already noted, the majority of instructions generated by a compiler are rather straightforward. It will seem reasonable that a control unit built specifically for those instructions and using little or no microcode could execute them faster than a comparable CISC. And the last point relates to anything that has to do with the utilization of instruction pipelining. RISC researchers feel that the instruction pipelining technique can be applied much more effectively with a reduced instruction set. We examine this point in some detail presently. So that's all from me. Thank you.
Hello and Assalamualaikum. My name is Nabil Umar bin Abdul Rahman with metric number 066512, and I would like to elaborate on the differences between RISC and CISC. RISC, also known as Reduced Instruction Set Computer, is a microprocessor architecture with a simple collection and highly customized set of instructions. On the other hand, CISC, which stands for Complex Instruction Set Computer, is a processor that has a large collection of complex instructions that range from simple to very complex. First and foremost, The difference between RISC and CISC is that RISC emphasizes on software to optimize the instruction set. Meanwhile, CISC focuses more to build complex instructions directly in the hardware instead, because the hardware is always faster than software. Secondly, RISC is a hardwired unit of programming in the RISC processor, while the CISC is a microprogramming unit in CISC processor. Next, the third difference is that the RISC requires multiple register sets to store the instructions, but the CISC only needs a single register set to store the instruction. Furthermore, when it comes to decoding of instructions, RISC has a simple way of executing it, while CISC is more complex about it. In addition, in terms of uses of the pipeline, it is simple in RISC, but in CISC it is difficult. Then, RISC uses a limited number of instructions, which results in less time required to execute the instructions. Meanwhile, CISC uses a large number of instructions that requires more time to execute the instructions. From here on out, my friend Muaz will continue explaining the differences between RISC and CISC. Thank you.
Thank you, Nabil, for the good information. Now I will continue about reduced instruction set architecture. Before that, hello and Assalamualaikum. My name is Muaz bin Azman. My metric number is 067282. I'm from SMSKPP. Next, it uses load and store that independent instruction in the register to register a program's instruction. And for the CISC, it uses load and store instruction in the memory to memory instruction of a program. Then RISC has more transistor on memory registers, and for CISC has transistor to store complex instruction. Furthermore, the execution time of RISC is very short, and for CISC, the execution time of CISC is longer. In addition, RISC architecture can be used with high-end applications like telecommunication, image processing, video processing, and so on. And for CISC, architecture can be used with a low-end application like home automation, security system, and so on. Next, it has fits from instruction, and for CISC, it has variable from instruction architecture. And for CISC, it has a variable format instruction. Then the program written for RISC architecture needs to take more space in memory, and for CISC, program written for CISC architecture tends to take less space in memory. Lastly, example of RISC, ARM, PARISC, Power Architecture, Alpha, AVR, ARC, and SPARC. And for CISC, examples VAX, Motorola 68000 family, System 360, AMD, and the Intel 8086 CPUs. That's all from us. I hope this video is helpful to make you understand better about reduced instruction set architecture. Thank you for your attention. Assalamualaikum and take care.